Welcome back, guys. Today we are back with another problem. Today's particular problem statement is finding the two smallest maximum sum in a possible subarray. So what we can see here that we will be given an array 4, 3, 1, 5 and 6. We have to find the two smallest sum of the subarrays. So let me just check and explain you how the solution will be 11 and how it is coming. Make sure you guys like, share and subscribe to the channel. Okay. So today's particular problem statement is two smallest in every possible subarray. So 4, 3, 1, 5 and 6. So we will do combinations of all possible subarrays. So what we can see also our constraint is we have to do it in O of n and O of O1. Okay. So what we can see in the dry run, 4, 3 is there. So with 4, what are the possible combinations? 4 and 3. So what are the smallest and the second smallest combination I can get? The smallest combination I can get is 3 and the second smallest is 4. If I add it up, I will get a 7. Now I will extend it. So from here, I will go here. Now I will go till here, from here and from here. Similarly, I will go like this from 3 to 1 to 3 to 5 to 3 to 6. Similarly, from 1 to 5 to 1 to 6. Similarly, last 5 to 6. Okay. So that's how I am going to do it. Okay. So with 4, 3 and 1, the smallest is 1 and the second smallest is 3. We will get a 4. Similarly, with all the values with 4, I will get the answer as 4. Now 3 and 1 add up to become 4. 3, 1 and 5 also the second smallest and the smallest. So this is the smallest and this is the second smallest. If I add it up, I will get a 4. This is the smallest and the second smallest. So I will add it up, I will get a 4. For 1 and 5, I am getting a 6. You guys can easily see. 1, 5 and 6, I will get a 6. 5 and 6, I am going to get an 11. So I can see the values which I will be receiving. The values, if I write down the values, 7, 4, 6. Okay. Now you guys can come up with a lot of approach. Like if somebody will say, okay, I can store the sum in a stack and I can just take out the element and see the maximum element of the stack and top elements. No, that's a cumbersome process and we are not going to do. This is the most easy way I'll tell you that how we can get the sum as 11, which is nothing but the sum of 5 and 6, okay, which is the last pass. So let us go and solve this. So this is a simple algorithm what I'll be using. So I'll be having an int max function. I will be passing the array taken from the user. I will have a max sum variable which will initially store integer dot min underscore value. As you know that the sum we have to get is a maximum sum. There will be some base cases. So let us quickly write the base case. The base case will be if our array of if our array dot length is lesser than 2. That means there are less than 2 elements. Then what I can say, I can return a -1. That is my base case. Guys, try to implement the base case on your own so that it will make you solve problems on your own as well. Now we will go till n-1. Why n-1? I'll come to that. For sum of every adjacent element. So this is my element and this is I plus 1. So if this is I and I plus 1, that's how we are doing. What you guys can see, I'm doing the sum 4 and 3. The sum is 7. 4, 3 and 1. The sum is 4. Like that. 3 and 1. Okay, the smallest and the second smallest. That's how I'm doing the sum. Now, how can I get the maximum sum obtained? My maximum sum will be nothing but my sum, comma max sum. That's how I can get the maximum sum. Okay, the time complexity is O of n and space complexity is O of 1. So let me just try and execute. So this is the code. I've written this thing. If it is less than -1 and if it is more than that, what I'll be doing is I'll be just simply go and solve the other part. So this is the problem statement. Okay, apparently over here. So let me just run it. Okay, no output. There must be some errors. Okay, so yeah, I haven't given the input the size of the array. So the size of the array, if I put the size of the array over here, the size of the array, then I will get, see, I'll get an 11. That's how I'm getting an 11. So this is a very pretty simple problem statement. So I'll be just writing or coding over here. First, I'm going to write my base case. If my array dot length is lesser than 2, then return -1. Okay, and after that I can write for int I equals to 0, I less than array dot length -1, and I can write I plus plus. Why I'm doing length -1? Because whenever we are taking adjacent element, there will be a point of time that the adjacent element goes out of bounds. So in order to prevent out of bounds exception, I'll be taking the loop counter as -1. I can say current, I can say just sum equals to array of I plus the next element, array of I plus 1. and I can take a maximum sum value. So int max sum equals to integer dot min underscore value. Okay, and over here I'll do is max sum equals to maximum of mat dot max of, I can write the max sum comma the sum which I'm calculating. Okay, and I can return finally the maximum value. Let me just quickly compile. So this code is working. If you guys haven't checked out my playlist, go to the YouTube. Okay, go to YouTube, YouTube and just check out my code with and a playlist. I have recently uploaded a lot of good playlist. This must be helpful for you guys. You guys can see I have uploaded the arrays playlist over here. If you guys want to check out the playlist of arrays, what you can see, there are 21 videos, and there, if you guys want to check out more playlists like linked list, then how many, we have 9 videos on linked list. We have a lot of videos, 22 videos on dynamic programming, and these are my personalized you can see my playlist which has got 83 videos on the DSA playlist. So this will help you overall build your concept and solve any possible problems which you guys can see in your placements. Make sure you guys like, share and subscribe to the channel. So it is a amazing uh, opportunity for me to help you guys with your DSA content. Thank you so much. See you in our next video.